Imagine you are floating, completely alone, 444 million miles from the last human being who will ever hear your voice. Below you stretches an ocean, the largest ocean in the entire solar system. Hidden beneath a shell of ice so thick it makes the Himalayas look like a speed bump. You can't see the water, you can't reach it, but something beneath that ice is moving, and NASA knows it. That's why they're not sending you there. Not yet, maybe not ever. From a distance, Europa is one of the most breathtaking things the human eye has ever photographed. It glows, literally glows. A pale, bluish-white marble suspended in the black, streaked with rust-red lines that crack across its surface like the veins of something alive. Scientists once looked at those images and felt wonder. They felt hope. They thought, this is it. This is where we find life beyond Earth. And they might be right. But here's the problem. The closer you look at Europa, the more it stops looking like a destination and starts looking like a warning. Those beautiful red lines? They're fractures. Deep, violent fractures torn open by forces so extreme that the entire surface of this moon is essentially broken. The ice shifts. It moves. It groans under pressures that human engineering has never been asked to survive. And beneath all of it, beneath hundreds of kilometers of frozen crust, there is a liquid ocean that has been sitting in complete, total darkness for 4 billion years. 4 billion years of darkness. 4 billion years of whatever happens when life has nowhere to go and nothing to fear. Before we even talk about what's on Europa, let's talk about the journey to get there. Because the journey alone might be enough to kill you. Europa orbits Jupiter. And Jupiter is not Mars. Jupiter is not even close to Mars. At its nearest point, Europa sits roughly 390 million miles from Earth. A spacecraft traveling at the speed of NASA's Juno probe, one of the fastest we've ever launched, takes roughly 6 years to make that trip. 6 years in deep space. 6 years inside a metal tube, bombarded by cosmic radiation, muscles dissolving in zero gravity, bones losing density at a rate that no amount of exercise fully prevents. By the time you arrived, your body would be a different object than the one that left Earth. Your eyes would have changed shape from intracranial pressure. Your cardiovascular system would have partially restructured itself. Studies on ISS astronauts, people who spent just 6 months in space, showed brain matter physically shifting inside the skull. 6 months. Now multiply that by 12. You'd arrive at Europa already broken. But that's not even the worst part. Because before you can even reach Europa, you have to pass through something that NASA engineers speak about with visible discomfort. Jupiter's magnetosphere. Jupiter is not just a planet. It is a radiation machine. The largest planet in the solar system generates a magnetic field so powerful that it traps and accelerates charged particles into belts of radiation that make Earth's Van Allen belts look like a warm bath. Inside Jupiter's radiation environment, the intensity reaches roughly 540,000 Rems per day near Europa's orbit. To understand what that number means, a dose of 400 Rems is enough to kill a human being. Europa receives over 1,000 times that every single day. NASA's Galileo spacecraft, a machine, not a person, just a robot made of metal and circuits, was so destroyed by Jupiter's radiation after repeated close passes that its instruments began to malfunction one by one. Its memory corrupted, its systems degraded. A machine, and it was dying. A human inside a spacecraft orbiting Europa would receive a lethal radiation dose in a matter of hours without extraordinary shielding. The shielding required to protect a human crew would be so heavy it would make the mission nearly impossible to launch. And even then, even with walls of lead and water tanks and every trick NASA's engineers could imagine, you would still be absorbing radiation. Slowly, quietly, every moment you were there, the invisible damage would be accumulating inside your cells. And this is where things change. Because even if you somehow survive the journey and somehow survive the radiation, you still haven't landed. You're still in orbit. And now you have to figure out how to get down. Europa's surface temperature sits around -160 degrees Celsius. That's cold enough to freeze carbon dioxide solid. That's cold enough that if you were somehow standing on the ice without a suit, your blood would crystallize before your brain finished processing what was happening. But the cold isn't the real problem with the surface. The real problem is the ice itself. That beautiful, glowing shell of ice that makes Europa look so serene from space is not stable. It's not solid in the way you're imagining. Europa's ice shell is believed to be somewhere between 10 and 30 kilometers thick, but it's in constant motion, driven by the tidal forces of Jupiter's gravity pulling and squeezing the moon like a rubber ball on a cosmic scale. The surface cracks, sections sink, new ice wells up from below. Entire regions of Europa's crust are described by geologists as chaos terrain, which is exactly what it sounds like. Broken, jagged, unpredictable fields of ice shards, ridges, and collapsed formations stretching for hundreds of kilometers. Landing anything on that surface, let alone a crude spacecraft, would be like trying to set down on a broken mirror that someone is slowly twisting in their hands. But it gets worse, because even if you found a flat spot, even if you landed perfectly, the moment you tried to drill through that ice to reach the ocean below, you would trigger consequences that NASA scientists are still trying to model. The pressure differential between the surface and the subsurface ocean is staggering. If you breach that ice shell without extraordinary precision, you could trigger a catastrophic venting event. A geyser of pressurized water and gas erupting from the drill site with enough force to destroy everything around it. We know Europa has geysers. The Hubble Space Telescope photographed plumes of water vapor erupting from the surface, reaching heights of 200 kilometers. 200 kilometers of pressurized water vapor, exploding upward from the ice. That is the environment you would be working in. And then there's the ocean. Europa's subsurface ocean is estimated to hold more liquid water than all of Earth's oceans combined. It's deep, potentially over 100 kilometers deep in places. And it sits under pressure. Enormous, crushing pressure. The kind of pressure that, at the bottom of Europa's ocean, would be roughly equivalent to being several kilometers beneath Earth's ocean surface. The kind of pressure that would require an entirely new category of submersible technology that we simply do not currently possess. But pressure is just physics. Physics is something we can eventually engineer around. What we cannot engineer around, what keeps the scientists up at night, is what might already be living in that ocean. Because here's the thing about Europa's ocean that changes everything. It's not just water. At the seafloor of Europa, researchers believe there are hydrothermal vents. Hot, chemically rich systems where the rocky core of the moon meets the liquid ocean above it. On Earth, hydrothermal vents are teeming with life, entire ecosystems that have never seen sunlight, that run entirely on chemical energy, that exist in conditions we once thought were completely sterile. Europa has had those same vents for 4 billion years, in a sealed ocean, with no outside contamination, no meteors breaking through, no surface contact, a completely closed system, cooking in its own chemistry, for longer than complex life has existed on Earth. Whatever is in that ocean has had 4 billion years to become whatever it was going to become. And this is where the fear becomes something different, something harder to name. Because here's what NASA is actually most afraid of. Not dying there. Not the radiation, not the pressure, not the temperature. The thing they're most afraid of is us. There's a principle in space exploration called planetary protection. The idea is simple and terrifying in equal measure. If we send humans to Europa, we will inevitably bring Earth with us. Human beings are not sterile objects. We are walking ecosystems. A single human exhales millions of microorganisms with every breath. Our skin sheds bacteria constantly. Our suits, no matter how well sealed, carry contamination. And if even one Earth microbe makes it into Europa's ocean, if one bacterium from a human hand somehow survives the journey and the radiation and the cold and reaches that pristine, sealed, 4-billion-year-old ocean, we will have destroyed the single greatest scientific opportunity in human history. We will never know if the life we find is Europa's or ours. And that's why the mission hasn't happened. That's why, when NASA scientists talk about sending humans to Europa, the conversations stall. Because the very act of going there with human bodies might contaminate the answer to the most important question our species has ever asked. Are we alone? We could send robots. We are sending robots. NASA's Europa Clipper mission launched in 2024, a spacecraft designed to make dozens of close flybys and study the moon from orbit. But robots can only go so far. Robots cannot improvise. They cannot respond to the unexpected. And whatever is in that ocean, if anything is in that ocean, it may require a human mind to understand it. But that human mind would poison the very thing it came to find. There is no safe version of this story. If we go to Europa and find nothing, no life, no chemistry, no signs of anything, then we have spent centuries and trillions of dollars confirming that the universe's most promising ocean was just water and darkness. We go home smaller than when we left. If we go and find something, if we drill through that ice and lower a camera into the black and the camera sees something moving, then we face a horror of a different kind. Not the horror of monsters, not the horror of something alien and hostile, the horror of a mirror, the horror of realizing that life is not rare, that it emerges wherever the conditions allow, that this universe, vast and indifferent and absolutely lethal to human beings in almost every corner of it, is somehow littered with living things. And if life is everywhere, if Europa has it, if the moons of Saturn have it, if the oceans beneath the frozen crusts of 100 worlds we've never visited are full of things that breathe and feed and grow in the dark, then the silence from the stars becomes something unbearable, because it means all those living things never left, never called out, never reached across the void. And maybe that means they knew something we don't. Maybe the universe doesn't reward the species that looks outward. Maybe the ones who go quiet, who stay beneath the ice, invisible and safe in the dark, are the ones who figured something out first. Europa is 444 million miles away, glowing like a lantern at the edge of everything we know. And whatever is beneath that ice has never once looked up. Maybe that's wisdom. Maybe that's the answer we've been looking for. Maybe we were never supposed to go. If this kept you awake, you know what to do. Subscribe. The universe has more nightmares where that came from.